Hello everyone, this is Saket. In this particular video, we are going to start VLSI Design. So, what is the full form of VLSI Design? So, very large scale integration. So, VLSI is the process of creating an integrated circuit by combining millions of MOS transistors onto a single chip. So, we are going to design a chip in which large number of MOS transistors are being connected. So, we are not going to basically physically design the structure, but we are using a software. We will design this particular structures. So for that purpose we use microwind softwares. So microwind softwares allow the designer to simulate and design an integrated circuit at physical description level. So let's move forward. So first of all, we have to just get some basic knowledge regarding MOS transistor. So what is the structure of MOS transistor? So MOSFET is metal oxide semiconductor field effect transistor. Let me just use my pen here. So this is just a full form of MOSFET, and here you can see that this is the structure. So in this structure you can see that this is source, this is gate, and this is drain. And this layer, whole layer, is SiO2. And this N plus and N plus 2 regions are N-type semiconductor. And this whole region, which is the substrate here, is P, which is P-type semiconductor, and this will be known as a metal here. So let's move forward. So the MOSFET will be subdivided into PMOS and NMOS, and there will be another category in which both PMOS and NMOS will be used, which is called combined MOS, CMOS. So first we will just discuss about PMOS and NMOS, then we will move forward to CMOS. So in PMOS here you can see that this is the structure, and here you can see that the substrate is N, and similarly in NMOS the substrate is P, and the symbol of PMOS and NMOS is this. Here in symbol you can see that here is some kind of small circular structure, and here it is not. So PMOS will be on when it will be 0, and it will be off when PMOS is 1, and NMOS is just opposite to it. So when NMOS is 0 it will be off, and when NMOS is 1 it will be on. So you must know these small basic things regarding MOS, so you can easily understand it and you can implement it on the software. So now we will start the CMOS implementation of logic gates. So there are some kind of rules which we have to follow. So here you can see that these are the rules. So always we have to use PMOS on the upside and NMOS on the downside. So this is the first rule which you have to keep in mind. And the V input which we will give, the voltage input will be given in gate. So the general structure you can see here is that the MOS contains gate, source and drain. So here you can see that this will be the gate, and this will be the source, and this will be the drain. And similarly in NMOS, gate will be this only, but here this will be drain and this will be source. So the next rule will be the third rule. So I will explain you this third and fourth rule after some time. So let me just move forward here. So we are going to implement different kind of functions and gates on the software. So we have to keep in mind some steps regarding that. So the first step will be write the equation of the given function or gate. So we are going to implement some kind of gates. So we will just write the equation of that particular gate. So then we will take the complement of that given equation, solving that equation using De Morgan's law. So we will use the De Morgan's law, and then we will solve that equation and make that equation more generalized, and then we will draw the circuit. So these steps are very important while implementing it on the microwind software. So moving forward, so here you can see that we are going to make a CMOS inverter. So I have told you that I will explain the third and fourth rule a little later. So here you can see that the equation of the inverter will be y is equal to a bar. So a is here the input and y is the output. So y is a bar, which means that it will be the opposite of the input. Means if you will give 0, then you will get the output 1. If you will give the value 1, then you will get output 0. So this is the NOT gate here. So if you give input 1, then it will give you output 0. So in the way of NOT gate, you can easily understand what is CMOS inverter. So consider case 1 when we are giving input value 0. So let me just show you the previous diagram here. So this will be the diagram of CMOS. So how this diagram is formed here. So the third rule says that dot will be parallel and plus will be series, and NMOS is equal to plus will be parallel and dot will be series. So here you can see that the number of NMOS and PMOS is equal to number of variables. So check here, the number of variables will be a, so only one variable, so we does not require any kind of parallel and series combination here, because the number of variables is only one. So we will get number of NMOS and PMOS only one, so we will connect them directly. So here you can see that this is the PMOS and this is the NMOS, so we have connected them directly, and we have given the voltage input in the gate side and taking the output from drain side, and the source is connected to the VDD V plus, which is plus 5 voltage, and the source is connected to the VSS is connected to the 0 here. So let me just move forward here. So first case will be when V in is equal to 0. So V input is 0. Then we have just saw that the PMOS will be active when it will be 0, and NMOS will be 0 at that particular time. So we can just open this circuit here. The NMOS is deactivated and PMOS is activated. So this VDD is equal to plus 5 will be just transferred into the V out. So our output will be 1. So when input is 0, then output is 1. So using this method, you can easily understand that how output is coming 1. And when case 2, when V in is equal to 1. So in this case, just opposite will happen. The NMOS will be activated and PMOS will be deactivated. So we have just opened this circuit here, and V in directly will go here, and here you can see that the VSS is 0. So this particular value will be get transferred into the V out. Hence our output value will be 0. So just opposite value of VA is coming. So here you can see that this is the working of CMOS inverter. So now finally we will design the circuit on the microwind software. So let's move forward. So this is the microwind software here, and we will design this inverter circuit here. So let's start with it. So we need one NMOS and one PMOS. So we will generate those structures here. So first of all we are generating PMOS. So we have just generated the required MOS here, and now we will generate NMOS. So here we have generated the NMOS also. Now we will connect the gate and the source and drain. So first of all, let me just connect the gates. So this is the polysilicon here, and we will just connect the gates. So this is the gate connection, and now we will just connect source and drain of the PMOS and NMOS here. So this we have connected here, and now we have to just give value of the V in the plus 5 voltage and the 0 voltage. So using this V supply we can easily give it. So here we have to give the VDD plus, and we have to just extend this particular area also, so that we can give VDD plus here also. So I'm just extending it further. So here I have extended it, and we will just give VDD plus here also. And finally we will just give the 0 voltage here. So here you can see that we have made the complete circuit, and now we will just give V in and V out. So V in will be the clock, so we will add the clock at the gate according to our circuit, and we can just write capital A and assign it. So I assigned it, and now we will just give output. So we can just write out here, and it will get assigned. And now we have to check our circuit here that it is right or wrong. If any kind of error will be there, then it will be shown on the screen. So we have designed our circuit and it is completely correct. So let's see the waveform. So using this button you can easily check your waveforms. So here you can see that when the input is 1, then you will get the output 0, and when the input is 0 you will get the output 1. So this is all about the CMOS inverter circuit. In the coming videos we will make different kind of gates, and I will explain you the correct use of the rule 3 and rule 4, in which the number of variables will be increased, and how we will connect different kind of NMOS and PMOS in series or parallel using that rules. So thanks for watching this video. Thank you very much.